Hey everyone, and welcome back to the channel. Today we're starting a new series looking at NumPy, which is a really powerful library in Python designed for numerical computing. So we're going to start with importing the NumPy library using the alias NP, which is just a common convention that allows us to reference the library with the shorter name whenever we're calling its many functions. And so the first thing we want to do is look at how to create arrays in NumPy. Arrays are the core data structure in NumPy, and they enable efficient storage and manipulation of numerical data. So we're going to look at creating two different types of arrays here, one directional and two directional. And so we're going to use the np.array function to actually create these arrays. In the first example, we're creating a one-directional array by passing a Python list of numbers 1, 2, 3, 4, and 5 into that array function. This list is then converted into a NumPy array, which provides numerous benefits over standard Python lists, such as faster computations and more efficient memory usage. And then in the second example, we're creating a two-directional array by passing in a nested list. So we have our first list, 1, 2, 3, but then we also have our second list, 4, 5, 6, nested into that list. And we're passing that entire list into the array function. And so each inner list represents a row in the two-directional array, resulting in a matrix-like structure. And you can see here if you were to print this output, your matrix would have 3 columns and 2 rows because that's the data structure of those two lists that we passed in. Arrays created in NumPy, you can start performing basic calculations using the NumPy functions. So here we're going to look at 3 basic operations: sum, mean, and standard deviation. So by passing in our array to each of these 3 functions, we can see by printing what the output would be the calculation it gives us. So the sum, if you add up all those numbers, 1 through 5, is 15. The mean or the average is 3, and the standard deviation is 1.41. Now, where these functions get really powerful and handy is when, say, you have another array. So we're going to create a second array, and this has the values 10, 20, 30, 40, and 50. And these functions get really awesome when you start performing element-wise addition. And so we'll do that with the first and second array. And so what we're doing here is we are essentially adding the arrays. So we're adding the first elements, which would be 1 and 10, the second elements, which would be 2 and 20, so on and so forth. And we are now printing that element-wise addition. And so you can do this element-wise operations with like the mean, the standard deviation, and a whole portfolio of other mathematical operations. If you found this video helpful, please consider liking and subscribing, and leave a comment letting me know what topic I should cover next.